So now we make it to the study of the inverse of exponential functions, and they're called logarithmic functions. If you look up the word and you look at the history, it's pretty old. It's from the 1600s, and it's talking about just basically a blending of logos and arithmia, which is logarithm. It's like a name or a type of number. Okay, so it's not much to the name itself. In fact, it doesn't roll very well off the tongue, but the logarithm function is, it's defined to be the inverse of our exponential function. Okay, so the topics, I think what I'm going to do, these are going to be kind of short videos. I'm going to do two of them for this section. And the first one's going to be dealing with, basically what are logarithmic functions, what do they look like? And then how do you have this equivalency between exponential and logarithmic expressions, okay? And then we'll cut and we'll go to another video. So let's begin here. So the inverse of an exponential function, okay, we've talked about inverses, and I left you hanging last time with this kind of a statement. I've got y is equal to 2 to the x. Let's play with 2. Then if I go for the inverse, I don't know if this is working for you, but we've been talking about it. The inverse function would be taking x and y and just changing their roles, okay? Okay, so this is the inverse function. These two functions here are inverses of one another. If you were to plot points here, x, y, you would get, okay, 0 gives me 0 power is 1, and 3, for example, gives me 2 to the 3 is 8, like we've done before. But if you do ordered pairs here, you would want to be plugging in for y, because that's the power. 2 to the 0 is 1, 2 to the 3 is 8, and of course they're inverses of each other. But the thing is, what we want to do is say, well, what is the inverse of this guy? And the inverse of this guy would be found by solving for y. How do we do that? What do we do? So we invent a function and a notation. And here it comes. Logarithm base 2 of x. Okay? These two guys are what we call in mathematics, well, it's down here too. These are equivalent expressions. And what that means in math, equivalent means if one's true, the other's true. In other words, for instance, if x is equal to 2 to the y power, then y is equal to the log base 2 of x power. So this guy here has the same ordered pairs. And if we play around with it just a little bit, it says, well, if I plug in 1, so log base 2 of 1, I should get 0 for y. And the other one, if I plug in 8, log base 2 of 8 for x, I should get 3 for y. And these are true statements. This is the notation. And this is the part that is, I think, one of the twistiest part for students is to get used to this new function and what it says. What you can think of a logarithm function is the following, okay? So let's play around with log base 2 of x, okay? What you're doing is you're taking a number, which is whatever number you want, you plunk it in, and what it does is it gives you, or us, the power of 2 that is equal to the input number, okay? It's equal to that. So it says the machine inside goes 2 to equals 8. It answers that question, It searches and it figures out, oh, the answer is 3, so out pops a 3. So the exponential, you give it a power and it computes. That's the reverse. The reverse would be 2 to the x, okay? And you say, I'm going to give you this number 3, and what it does is, it's going to go 2 to the 3, and out pops, guess what, an 8. Notice if you put these back to back, by the way, you start at 3, and you compose them, like you get an 8, then you take the 8 and you put it into the log function, you get the 3 again. They reverse each other. These are inverse functions. Pretty weird, huh? As inverse functions, what I did on Desmos here is I graphed y is equal to 2 to the x in red, and I guess in blue what I did is I graphed y is equal to log base 2 of x. Okay. These are inverse functions. Their ordered pairs are reversed. So for example, this point here is 1, 0, and this point over here is 0, 1. And they reflect across that line y equals x. I put that in green. So this guy is the line y equals x. And they reflect across it perfectly. Okay? So these are inverse functions. And what we really need to get used to is this guy's notation if you've never seen it before. So hang in there. All right. That's an introduction to what a log function is. That idea of inversing or inverting each other. It looks something like this. Watch. Log base 2 of, and in here you put the exponential. I'm going to compose it like 2 to the x is merely x. If I go the other way, I go, and we don't see this too often, but we see it in other classes, not e, 2, e's later, 2 to the log base 2 of x is also equal to x. Now that freaks us out. This one right here is helpful though for our class. If ever you see a power and a logarithm with the same base, they cancel each other out, like the square and the square root cancel each other out. More on that later. Okay, so the last thing on this video is some of the homework that you do in this section, and it's basically the equivalent form. The equivalent form is basically you've got an exponential. Say we've got oh gosh, how do you do this? Y is equal to some base, whatever it is, to a power like m. And then if we turn that around, if we do the inverse, it goes like this. It goes, oh, well then, oh, let's put the x up there. That makes sense. Okay, so that means the inverse would be x is equal to b to the y, but here comes the real inverse. Y is log base b of x. So I'll get rid of the middle guy. Actually, I'll get rid of the first guy, and I'll say that these guys are equivalent, okay? And it'll say x is equal to b to the y, or equivalently, y is equal to log base b of x, okay? What you want to pay attention to, in fact, I might even color code this a little, is the base is b here and also way down here. Okay. Okay. So let's do this. Let's turn these guys into equivalent statements. Ready? Okay. So the first one is this guy right here. 3 to the 4. What happened there? 3 to the 4 is 81. Okay, it's going to do that. Let me get rid of you. All right. So how do we write that as an equivalent statement? What we do is we have a statement that is in exponential form, and we're going to switch it to logarithmic form. We're going to write it as an equivalent statement like we were talking up above. So what you do is you go, I would say log base b, which is in this case 3, of something is something else. Okay, watch this. All right, this exponential will take a 4 and it'll give you an 81. I don't know why it's creeping down like that, but that's really strange. Okay, the log will take the 81, okay, and give you a 4. Okay? Wild, huh? So remember, logarithms give you powers. This particular phrase right here says, apparently, 3 to the 4 power is 81. Because log base 3 of 81, it gives you the power of 3 to make 81. Okay? So instead of taking a power and getting a result, like taking a power of a number, this says, here's the result. What is the power that we took? It's backwards. That's all there is to it. Do the next one. I think I'll use the same colors. They're so pretty. We'll say, okay, the next one would be log, what's the base? 2 of equals. Turn it around. You get some good points on the test for doing this right? Okay. So instead of taking a -3 and getting a power as a power and getting 1/8, yeah, that's right. We're going to take 1/8 in the logarithm and we'll get the power -3. Okay. And one more. All right, we're going to say log base something of something equals. Let's put the somethings in the right spot. What's the base is e, correct. The base is e. And then it does the power backwards. It goes, instead of saying, oh, take a 2 and get 7.3891, we're going to take the, I should have made more room here, huh? We're going to take the 7.3891, and we're going to get, what is it? 2, right? And that's that. What is E? I've hinted at that guy, and I'm just throwing him in there for fun. E is an irrational number. If you look on your calculator, you have 2 buttons, okay? One says log, and above it you'll see 10 to the x. And then there's another one that you might not notice, and it says ln, or something like that, ln. And above it you'll see e to the x. What the calculator designers did is they put the inverse functions together. There's a log button, but the inverse to that is base 10, 10 to the x. Okay, might as well talk a little bit about this. Y equals 10 to the x, and then y equals log of x are inverses. This guy's called the common base, or common log. Okay. Then there's this other one over here. It says y equals e to the x, y equals ln of x, and this is the natural log. If we get to that section, which I doubt this semester, but if we do, that's the very last chapter or section of chapter 9, we actually play around with e. You know, that's a great thing to cover. If we make it, we make it kind of thing. Okay. All right. So that's what E is all about. In fact, it's so common, I should say it's the natural base. Another name for this is ln of 7.3841 or whatever it is, 91. Okay, so instead of that, it could have been ln. Let me write that down. Ln of said number. And 7.3891. Okay, so that happens. And you'll see that, and it's good to know, I mean, there you go, it's base E. All right. Now we're going to go back the other way. That is to say, they're going to give us a logarithmic expression, and we're going to write it as exponential. And the exponential one goes like this. This is a really good exercise. It helps you solve equations later. So if we look at this guy, we notice that the base is 5, so we'll go, okay, it must be 5 to something equals something else. Okay, so this is, again, where you turn the numbers around. Is it 5 to the 125 equals 3? No. It goes the other way, doesn't it? You can kind of predict this one. 5 to the 3 is 125. These go fast, don't they? Okay. The next one, what's the base? You got to look for the base. In fact, I do it this way. In my mind, I go 64, ba-da-da, da-da-dee. That is to say, 64 is the base. What's the power and what's the result? Okay. Well, the power is always over here on this side of the equal sign. 64 to the 1/3 power is equal to 4. You know what that is? It's saying the cube root of 64. Do you see that? The 1/3 power is the cube root. Okay. We got one more. What's the base? 10. How do you write it? Well, you go, I've got, in this case, 10 to something equals something else. So what's the power? It's on the other side, -3. And what's the result? 0.001. Yeah, 10 to the 3 is the same as 1/1000th. 1 over 10 to the third, or 1/1000th, and there you go. So we're getting used to, in this section, the logarithm notation, what it means, how it fits in with the general picture of exponential functions. We're observing that they're inverses of each other, and we're writing equivalent statements, which will prove helpful later on. All right, one more video for this section.